Good day everyone. As we talked in our previous lecture, let's start with developing our first ball game. In the projects menu, click on new, click on the 3D object and say name the project as roll 1. Look at the location. This is the location where your projects will be saved. Right now for me is the D drive and the Unity projects. After you have done with this, click on create. Give it 2 minutes to actually load all the packages and the templates as required by the 3D game. Now you can see the window which is of Unity. Now the first and most important thing is let's save the scene. Let's save the scene as roll 1 in the scenes folder in the assets menu. As I said, it's better to work with a new scene rather than working with a sample scene, because many times what happens is the sample scene crashes as you make your objects heavier and heavier. So it's better always to make a new scene for the safer side. As you can see in the scene, there is a main camera and the directional light. If you click on the main camera, it shows the preview of what the camera looks like in the actual world in the game view. So always keep an eye on this view before you actually execute the game. Now, let's begin with developing our entire game. In this lecture today, we are going to first develop the environment, the player, and moving the player. So we'll be looking at these three things today in our lecture. First, let's make the ground. For making the ground, we select 3D object and a plane. I'll just on the auto generate lighting. This is just to make sure that the lighting is proper on the screen. You'll see a plane, a 2D plane with a fixed y-axis is shown in the scene. You can see over here that the scale is 1:1:1. Now, first what we do is first name the plane as ground, because this is the ground over which your ball will be rolling. So this is where we have to rename it as the ground menu. Then we'll increase the size of the plane to 2:2:2. There are a couple of ways to do it. So if you can see the scale, you can see a small arrow actually coming up. And you can see that the size, as I move this arrow, the size on the x direction increases and decreases. This is one way to do it. Another way is to actually put a value to it. So I'll put the x value as 2. The y value, I'm keeping it as 1 because ideally a plane is a 2D object with a very fixed thickness. So even if we change this thickness, it will not change the plane. So what we will do is we'll just keep the value as 1 in the y-axis, and in the z-axis we'll put the value as 2. So you have a 2x2 size of the ground over here. One thing you have to make sure, if you see reset over here, if you reset, all these values will be made to 0. Now it is important that you reset always in the beginning. I forgot to tell you that first always reset, because whenever you create an object, it is created in a random space, and you always want to have all your coordinates with respect to the origin. So always whenever a new game object is created, always have the position of the object at the origin. So over here you can see 0, 0, 0. Again, I'll change the scale to 2, 1, and 2. It's a 2x2x2. It's a ground of 2x2x2. Now, once the ground is made, let's create the player now. Save the scene first. It's always good to save the scene in Unity. Let's create a player. For us, the player is a sphere. Let's create by clicking on this plus menu, going to the 3D object, and clicking on the sphere. Over here, again, as I said, see, whenever you made a new game object, it is placed randomly in space. You don't want to do that. You first always have to click on this menu and say reset. So if you see reset, the sphere got placed at the origin. over here. So it's at 0, 0, and 0. Always and always make sure, because many times what happens is you forget this step, and then you sort of have to do a calculation of what the dimensions would be and how would you move the object. So it's always better to keep it with respect to your origin. By default, whenever you create a game object in Unity, it is created of a unit length. So if you see the scale x, y, and z, the size of the object is unit. So what happens is the object is always made of 1 unit size. Right now, what you can see is the sphere is kind of embedded in the ground. Now, if you can see, if it's just half the sphere, I want my sphere on top of the ground. Okay. So now what I will do is I will ideally raise the sphere by a position of 0.5. Now I will raise it in the y-axis. This is the y-axis. So I will raise it by 0.5. So now the sphere is ideally sitting on the ground, as you can see over here. This is what you would want. Next, we add a rigid body component to the sphere. Now we want the sphere to move like a rigid body under the forces of the physics. We will definitely look at how we can control the sphere using our inputs, but ideally the sphere moves under the physics forces. So we need to add a rigid body component to the sphere. So let's add that first. You click on add component over here. As you can see in the menu, inspector menu, first click on the sphere, then click on the add component, and you add a rigid body. You write the rigid body in the search menu, you see the rigid body and click on it. So now a rigid body component is added to the sphere. Next, now what we want to do is, as we looked at it in our game also, we want to move the sphere with respect to the input that we are giving. Okay, so for that, what we need to do is we will need to create a script. A script is basically used to control the motion of a game object. Depending on how you want to give the motion, it controls the way that you want to do. So make sure that you actually add a script. The way you do that is first go to your project menu. In your project menu, go to your assets, create a new folder called as scripts. Now go to your sphere, click on add component. Over here, a new script, and let it say player control. Player control. You will name the new script as player control and click on create and add. Now let's see where the script is. Oh, over here. Now you can see that the script is added to the sphere. Now if I click on the script over here, it kind of gives you a preview. It's a preview of whatever is there in the script. You cannot do any additions over here. For additions, you will have to open the script using a visual editor such as Visual Studio or any of the editors where we can edit the script. For our convenience purposes, we'll be using Visual Studio. Now, before doing that, I'll just drag and drop the player controller script in the scripts. So over here, you can see in the scripts that is being added. Now let's edit the script. So if you click on this three dots over here, you can find edit script. This is the initial. So as you can see on my screen, I have opened the script in Visual Studio, and this is the initial couple of lines that you see in your script. So what we will do is now we will work with these lines to actually make the ball move. Okay, so for the safety purpose or making sure my script works, so what I have done is I have taken my original script and I'll be using that script to actually make this script also. So it is for convenience purposes, but so that I can explain you each line sentence by sentence rather than spending time on writing the script. So first, for that, we'll start with adding. So I've removed all the content that was there earlier. So earlier there was void start, void update. I've removed it all. So we will add it step by step so as to understand what each step means. So for that, let's start with editing the script. So now what we want to do is we want the ball to move horizontally as well as vertically. So for that, if you look at the script, we over here, you can see over here that there is a float horizontal, move horizontal. So what these two commands, we start with these two commands where we are telling the we are telling Unity to get us the axis or the inputs of the horizontal and the vertical position. Now before that, what we will do is we'll write here void fixed update. Now, and what I will do is I'll copy the float move horizontal and float move vertical from over here. Again, I request the students to write this script down. It's very useful because it will give you an understanding of what all these things are. I'll explain you. So first, these two lines are basically it gets the input about the horizontal and the vertical. So if I have to move, if I have to give an input, say move horizontally or vertically, it gets that input and puts it in a variable called as move horizontal and move vertical. Okay. Now next, what I will do is go to the start. Now, since we have to first understand that we have to get that rigid body, we have to get that rigid body component from the Unity. Before understanding the input, we have to get the rigid body component from the Unity. For that, first we create a private rigid body variable. This variable we get it so that we can get the rigid body from the Unity, so that we can understand its inputs, we can understand how it's working and all. So please keep this thing in mind. Next, we use a void start. So void start is basically whenever you start a Unity game, these are the scripts or these are the things that will be executed in the beginning of Unity. What I'm doing now is I'm getting the rigid body component from the Unity part. So I got the rigid body component and I have assigned it to RB, which is a variable over here. Next, what I will do is I'll get the vector movement. So whenever we move, we get a vector movement. And as you can see over here, you get the horizontal and vertical. So if you see this part of the script, over here, let me explain you what this is. So here, what we are doing is we are getting the vector of the motion of the ball. So we are getting the vector 3, which is a variable type where the move horizontal and move vertical are the x and z movements. Now the y component is 0 because you're not moving in the y position. You're only moving in the x and z position. Your plane is the xz plane. So you are getting that movement and you're assigning that to a vector 3, a variable which is called as movement over here. So you're doing that. Now once you do that, what you want to do is you want to add the force. So you want to add that force and give it to the ball. So whenever there is an input, you want to add that force and give it to the ball. I'll remove the script. I'll explain you what exactly means. So what has happened is you got the vector 3 movement and now you convert that movement into force using the add force based on the movement of the vector. Now let's see how this script is actually running in Unity. Let's go to the console menu, no errors as such. If you click again on the script, you can see that the updated script over here, the preview of the updated script. Now let's run the game and see. Wow, the ball is moving. It's moving as per the command given to it, but it's moving really, really slow. Wow, it's really very difficult to play the game like this with a slow movement. What if we could control the speed? How much fast do we want the ball to move? So that's where in the previous thing you saw the speed variable. The speed variable over here is given, so that has to control the speed of the ball. Now, one thing you have to see over here is first when we create a speed variable. and that speed variable is public in nature. Now, one thing to keep in mind in Unity is whenever there is a public variable, you get access to that variable. So, the person who is working on Unity or can get access to the speed. He can define a value in speed. Whereas a private variable, the person does not have access. So, a public variable always can be edited. So, if you see over here, I've added a public float variable of speed. Now, if I go back to Unity, I click on sphere. See over here, you can see the speed variable. So over here, I can add the value of speed over here. So that's the difference between a public variable and a private variable. So make sure you keep and understand that whenever you want access or want to edit that values through this inspector menu, you make that variable public. Else you always make it private because you don't want anyone changing those values. Now let's go back. Now I have added the speed variable over here. So what I will do is I'll add it in the add force because what I want to do is I want to multiply that movement that I'm getting off from the inputs into the speed so as to get the faster movement of the ball. So what I'm doing is movement into speed, which is basically the motion of what the ball is. Now let's go back. Let's run the game now. Oh, why is my ball not moving still? I don't see any errors in the console, but why is my ball not moving still? One most important thing that I forgot to do is, can a ball move with a speed 0? Right now my speed is kept 0. That means there is speed into movement is 0. That's why even though my script and all are working fine, my ball is not moving because my speed is 0. And this is a very common mistake which students make, that they forget to put a value to speed. Let's add a value, say 100, to the speed value table, and let's play it now. Wow, that's uncontrollable. Let me play it again. Oh, that's really fast. You might want to now slow down the ball now. Now let's say I put a value of 10. This is more controllable. This is more controllable. This is much more controllable now. Now, one thing I would recommend is you put your main camera such that you're able to see the entire field. So I'm using this preview menu to actually visualize how my camera is looking. So from the top, you can see how my game actually will look like. And the similar variables are being changed over here in the position and rotation. So I am positioning my camera such that I can see the entire field comfortably so that I can look at the motion. So let me play it. I play the ball game again. See, now I can see the entire field and I'm able to move the ball with my WSAD keys and at the same time look at it comfortably. See, it fell off the ground. One thing I have to make sure is my motion of the ball is just restricted on that board that I can see. So for that, I'll add balls around those around the board now. So let's add those now. First, so I'll be adding these walls using cubes now. Let's create a cube. So the downward menu, the plus downward menu, 3D object, cube, and let's name it as wall one. Let's take a direction. Again, you can see the cube is created in random location. Let's reset it and create it at, just for convenience purpose, I'm just going to hide the sphere. Also, one thing I forgot to do is rename the sphere, and let's name it something like a player. Let's name that a sphere as a player. Now this wall is created. Now I want the size of the wall such that it is 0.5 times 10, 2 times in the direction, and 20.5 times there in the z direction. So you can see over here that. So this is the wall I want to create on both the sides of my board. Now let's do that way. So now this wall I have created. Now, first one I'll do is I'll just place it on one side. So the way I've done it is I have actually added coordinates. I have put the x-axis as -10 because it's 10 units ahead of me. So -10, 0, 0. So that puts it clearly on the other side of the wall. Now, what I want to do is I want to create a similar wall on this side also, on the opposite side also. But before doing that, I want to make sure that I organize all these walls together. So Unity has a wonderful feature called as an empty child. So you can create an empty child and empty. What we are going to create is empty. You are going to create an empty game object which will hold other game objects. So this is the beauty, because now if you have many walls or many players or many other things, you can all group them together like you do in the folder. You can create folders to actually group all the Word files or Excel files. Similarly, you can create an empty object to group all your game objects. To create an empty object and name it wall. Again, make sure the empty object is also at the origin. It's at the origin. And then what you can do is simply drag and drop this wall in this empty game object. So it becomes like a child of the empty wall game object. Now what I want to do is just duplicate this wall and put it on the opposite side. So what I'll do is I'll use the Control D, and this is a second duplicate wall that's created. Now, just to be sure that I want to put it on the other side. So if this was 10, I'll just put 10, 0, 0. So it's created equally on both the sides of it. So I'll just rename this as wall 2. Now similarly, I want to create walls which are there on the opposite side also. Okay. So now what I will do is I can either take each of these walls and rotate it by 90 degrees and put it over there. Or what I can do is even something more simpler, is I can create a new cube and call it wall 3. First, make sure it's at the origin. Okay, 0, 0, 0. Okay. Now, what I want to do is I want to increase in x direction by 20.5. Y direction remains the same. And z direction, do it as 0.5. Okay. And I want to move it by 10 inches on the other side. So you will see that the wall is moved by 10 inches on the other side also. So the wall 3 has a scale of 20.5, 2 and 0.5, and it's 10 units in the z direction. Now similarly that we did in the last case, we will create a duplicate of this and add it to the other side. I'll create a duplicate using Control D, name it wall 4, and create a duplicate on it on the other side. So this is my ground with the walls around it. Let me activate the player again. Okay, now I can see the player and the walls around it. Let me just play the game and see whether my player is staying restricted within the walls. Yes, now it's not falling. It's staying well restricted within the walls. However, what I see now is my entire game is white in color. In our next lecture, what we will do is we'll look at the materials, how we can add material to make it a bit nice looking. So instead of having it all white, can we make it a better looking? How do we improve the lights? How do we improve the cameras? So in our next lecture, let's focus on the cameras, lights, and materials in for our game. Thank you very much.